Digital transformation is one of the keys for engineering and product development companies aiming to stay competitive. In this excerpt from the recent Siemens Users meeting, Madison Rye, Saratech's VP of PLM and Application Engineering, breaks down why digital transformation is important, how to approach implementation, and the tangible benefits it can deliver. Enjoy.
Just out of engineering school, mechanical engineering, I have my master's degree, I'm ready to go. And I go in to design this gear housing, and I'm looking at it like, wow, okay, I've worked on cars all my life, but man, I never thought about how am I going to make this thing. I know serviceability because I've tried to, service before, but they had me work on the line for 2 weeks, and I worked with a guy who had been manufacturing these things for years. And I learned an immense amount from him. I learned how to make this, design this so that it could be truly made for to be made in manufacturing, for service, for quality. I learned a tremendous amount from the people there on the line. If I hadn't had that experience, I wouldn't have gained that knowledge. So people have knowledge, but how do we share that knowledge in a way that we can get it across the whole company? Well, the next step is digitalizing your data, and I think you brought this up, it's got to be digital. You've got to be able to share the data digitally, so all data has to be available in digital form. And it could be data, but again, about the process, the product, the people, anything that revolves around that, competitive information, anything that revolves around that. So now you have a lot of data, right? Think about your product life cycle. You've got from conception to end of life, whole lot of data, analysis paralysis, right? Insight, we need tools that help us develop insights about that data. We need something else to be processing all that data, crunching through it, and delivering us information we can use. And that's what the meaningful insight is in the second part. But now we have insight, so now we think, oh, okay, I need to change something. We have to have an action plan. So the next thing is actions. We have to have a clear strategy, and then we have to measure the results. So we've made a change, now we've got to measure those results, because then we can go back and take those results and make them a part of the new, richer data set and continue from the beginning again. So this loops back so that we're continuously improving all the time based on what we learn. So we talked about the product life cycle. This infinity loop represents your product life cycle. So it could be hardware, software, electronics, everything together, your whole product. You start at number one with, and anything you start, any program you start, you've got to have a target set of requirements, a target schedule, and a target cost. You move into quoting and ordering, product design, development, V&V, testing and analysis, manufacturing planning, operations, may or may not have shipping and logistics or installation and commissioning, maybe you're outsourcing that, whatever. Some of these you can outsource, some you have. Some people have all of them, but product service. And then the value engineering, just like I talked about taking all of that data and putting it back into engineering so that we have a new, richer set of data from which to work. This is your product life cycle. Everybody is about digitalization of this product life cycle so that we're not taking stuff out into an Excel spreadsheet, typing stuff in for manufacturing, and then putting that into the ERP system. That breaks this infinity loop. And it causes, could be errors, it causes time, causes issues. We talked earlier about CAM, taking CAM out to master CAM, taking analysis data out to another tool. Anytime you're doing that, you're kind of breaking the chain here, and you're causing rework sometimes and time consuming, and then prone for errors. All of this data that you see here is the digital twin. It's not just your physical or your virtual representation of the physical thing. It's not just a CAD. It's all of this data that gives you that insight that you need when you're trying to make a change. Then the digital thread is using that data to flow along this product life cycle without interruption, without that removal and manual intervention. So what do I mean by this in real practice? I mean, that's a pretty picture, Madison, but what do you mean by this in real life? Well, we're working with a customer now. They have Salesforce. We're going to talk about systems in a minute. They have Salesforce. They're using a customer portal so that people can go in and pick the options that they want. And then that is driving the product configurator in Team Center. No, if it's not a custom thing, it's a order, and I'll talk about custom in just a minute, but if it's a standard product out of the catalog or off the dealer floor, whatever, You can get from the 150% BOM right down to 100% BOM out to manufacturing with bill of process, bill of equipment, all of that per plant with instructions and everything with no intervention from engineering. That's a huge time savings. When you have custom products, there's another tool called RuleStream. What you can do there is you put rules around what you're allowed to build, and then you allow the product to make those variations for you. We've seen this in truck trailers, a number of different things where basically you're making it longer, bigger, wider. It'll make the new part numbers for you, and it'll put that into, and then somebody just has to do the engineering review of, is this correct, instead of the busy work of putting it together. Now, systems-wise, this comes from also, Harvard Business Review, which is what the last thing was from. This is, 2 slides ago, of the critical components of digital transformation. So I cite my sources. But this also comes from like independent analysts. What systems are really important for manufacturing companies? Because a single source of data doesn't mean one system. It means a single set of data that's shared across systems for your product. CRM, this is really important. You got to have customer, information, sales information, forecasting, all that stuff. Salesforce, number 1 there. ERP, you have to have, you have fiduciary reporting responsibility. Financials, you have inventory. All that happens on the ERP side. PLM, all the way from requirements to handoff to manufacturing, everything happens engineering-wise in PLM. And then MES, manufacturing execution. This is how are you going to make it? So is the person there at the cell, does he have the right tools, are the right piece parts there, the right instructions? Are the tools calibrated? Has he been trained? The cycle time, eventually tack time, all of that comes from MES. I've seen a lot of times where ERP says, oh, hey, we can do MES, don't worry about that. We got a module for that. Oh, MES says, no, you don't need ERP, you just need a module. Actually, that's not true. These systems are important because you want something that was grown up to do that function. For example, ERP, SAP, they've had a, they're standard in the ERP world, right? That's like the gold standard in ERPs. They came up with SAP PLM, and they've discontinued it now for discrete manufacturing because they realize that's not their core business. Their core business is ERP. Our core business is Teamcenter, is PLM. So they partnered with Siemens, and now they're using Siemens as their discrete manufacturing PLM, and we have a very tight integration now with SAP. So that's just an example of the system. So now that you have all the data, you have all the systems in place, you're getting those insights, you're getting that continuous loop of feedback, and you're rolling. Now you can really take technology and apply it to the user experience, whether the user be the customer, the employee, or whatever. 3D printing. As soon as we get a handle on metal printing, we're going to be able to print our replacements in the field. Heck, we're doing this at home all the time. If I have a plastic part, my Roomba, I needed this little plastic roller part. Scan it, print it, no problem. Once we get a handle on the metal printing, this is going to change, shipping all over the world. It's going to be able to manufacture stuff in the field that you need. We talked about analytics and AI. You're going to see augmented reality later. Cloud computing, I hate the word cloud. I don't know why, I just don't like it because it's really just somebody else's data center you're using. Everyone thinks some nebulous thing up in the sky. It's not, it's just somebody else's data center. But anyway, the cloud really has changed things too, because now for simulation, you can go and rent somebody else's cluster to use. You don't have to buy that hardware. You don't have to maintain that. It's not your job. You're not an IT person. You're trying to do your job and figure out how to design this product. You can do things such as, like, we offer a service with bring your own data. So you don't do anything but show up with your data, we load it, and you go. You don't have to worry about anything else. Digital twins we talked about. Oh, Internet of Things. My gosh, my refrigerator called me the other day and said, hey, the door's open too long. I'm like, hey, why aren't you calling my son then? But anyway, there are refrigerators now that scan as you put things in them, and they know now when you're using those things. This is changing our lives. These things make things, the easy button for us to do. So anyway, this is what can change, take that to the next level. Now that you've got everything connected, you've got all the information, you've got your data, you can use this to really improve experience and make things, you're driving to better, faster, cheaper, right? So where do we start? I mean, that's the biggest thing, is this is a big picture. This doesn't happen overnight. Most people have develop their systems. I know you were saying, Drew, earlier, you did all this research, you started putting your stuff in place as you grew. You're doing this over time. You're not turning on a switch overnight and having the ability to do. So when you look at, and you're lucky because you're a startup, so you have that not history of all these years of doing things on this other way or all these old legacy systems, but what you can do is take a look at where you are today, and then where you want to be in the future. And you don't bite off that whole chunk at one time. You look at little stair steps to get there. So you need to have, and I've seen a lot of people do this, $2 million sunk in this one company, 2 years, they still hadn't gone live with a new system. You're taking off too much. You got to show the business value first. We've got to let the business people know we're providing value. So 6 months, you should be at minimum, really up and running and getting your people in, whatever it is, whatever change you're making. And not only that, but it has to be based on business value, because I've seen a lot of times people say, hey, we need ERP, we need this, we need that. You have to start with the business requirements. What are those business requirements that are needed? What's the biggest pain the company is having? And what we do is we look at this through a system called Rice scoring. We interview all the people, we look at what issues you're having today. Here's your starting point, here's where you want to be. What issues are you having today? What's the biggest bang for the buck that we can do today to make a change that takes that first step? We get that ROI, and then we take the next step. And we use that to drive the cycle so that you can stair step your way to the future of where you want to be. All based on business requirements. And then, we use agile methodologies, really kind of waterfall plus agile, because that first piece you want to look at implementation wise, you're going to have to take a chunk and put it, in place, let your users get used to it. But then from there on, you add on pieces depending on what the business need is, what the ROI is going to be, and then you, again, step your way through that in an agile mentality. You can look at epics and drive down to the stories and so forth from there. Support-wise, organizational change management is critical here. If your users are not on board for a change, they're going to I've seen this happen. They're going to reject it. They're just not going to use it. We worked with a company that had been acquired by another company who wanted them to use something other than Solid Edge, and they did not want to do it. So 17, they were on like version 17, and we were on, 2025 or something. But they were so many versions back. They weren't paying maintenance, but they were still using that tool and not using Creo because they didn't want to do it. So no matter what the tool is, if the users aren't on board, they're not going to buy into it. And I think you were saying that earlier too, Drew, about, they've got to be involved in the change. They got to understand why it's better for them. They've also got to understand, if I've got to put some attributes in around my data up here and take some more time, how does that help my colleague downstream? How is that making finding things so much easier for them? What's that time savings to them? They've got to understand what the change is. They've got to feel a part of it and buy into it. So support, measuring adoption, and making sure that they're on board is critical. And this is just an example of some of the things that we've done where, you take, you take the first phase. Usually it's getting control of your engineering data, trying to figure out how to get that captured. And then the next step you can take is maybe change management or maybe some advanced workflow. And then the next step, you add your ECAD in, so you have a full BOM. Then you do BOM management, where you have software, hardware, and electronics all in the same BOM. And then you have an engineering BOM from the CAD BOM. So you have that engineering BOM, then you move to manufacturing BOM with the bill of process and all of that. Have a global BOM, have plant BOMs, everything updates. Everything's tied back to the source that it originated from, and you have true BOM management then. And then maybe moving on to the ERP connection. So now we push that right into ERP. Nobody has to type anything in, and you don't, have any manual work on that. There's a company we just worked with that had 3 people. That was their job. Type into ERP the BOMs. Three people full time. So, you can take those people and then use them for work that's not busy work. That's actual value add work instead of the busy work. So that's what that was all about. So anyway, that's probably a lot more than you wanted to know about digital transformation, but hopefully I've helped you understand this is real, this is happening. Why is it important? It's because if you've seen from history, and I can think of 1,000 examples, one of them is They used to, in every factory, when factories first started, they had a big giant engine in the basement, the motor driving everything in that factory. There were belts running up to every floor. Every machine was tied to that one. Guess what happened when that thing went down? The whole factory was down. So actually it was Werner von Siemens who helped adapt the electric motor to be used on each machine. So now you have each machine, if it goes down, no big deal. I can replace that motor, but the rest of the factory is still operating. So people, it took 25-ish years, but people who did not adapt to that went out of business. I can think of a CNC, a guy I knew who was a fabulous machinist, did racing parts for all the big three. He was fantastic, but old school, you know. He didn't get on board with CNC, and now his competitors could make very complex things. They could be programming another part while something was running. And that doubled their capacity very quickly. And he went out of business. So, you know, look at what's happening with the retail industry. I mean, it's you hear every day, businesses are being affected by digital transformation. And, you know, it's our job, it's Siemens' job to really make us aware of these technologies that have, you know, are available to you to enhance and to connect these digital threads for you. So that's what we're here to do today. So thank you for your time.